Okay, so that will help you to understand and you can develop your skill in machine learning. Okay, there is a website called Canium. Okay, so many books are available and videos in YouTube also there, so you can use it fully in Tamil. Okay, so the concepts which you want to learn, you can easily learn through these books. Okay, this is one website and you can download the PDF of the book and you can use it. Okay, so these are the teams. Okay, they created very good things. Okay, and we have another website towards data science, as I already insist in the morning. Okay, so towards data science, every day they posted different articles regarding technical only. Okay, so many different areas they project in different applications. It will be more useful to start your work. Okay, this is another website towards data science, and the third one is the analytics vidya. Okay, it's an excellent page. You can have a lot of articles inside. Okay, so any technical content regarding machine learning, Python, and deep learning. Okay, so all those articles are available in the websites. Okay, so you can use it. This is another one. And YouTube channels, I recommend Edureka and another
I would like to explain Bitcoin in a very simple
Code Basic. Excellent tutorials are available here. You can learn topics from the YouTube channels. Okay, this is the basic thing. We will move to directly to our content. Okay, so here I'll start my Jupyter. So my Jupyter gets started. Okay, so I will open the image processing folder. Okay, so we start with the basics of image processing with the scikit package, scikit image package, and now we move to image feature extraction. Okay, so image feature extraction. Before we move to feature extraction, I will show you some simple program. Okay, so that will help you to understand how machine learning gets work. Okay, so already I explained iris data set. Okay, you can see here. I will show you CSV file. Okay, I have also R file for Weka. Okay, now I'll open iris file. Okay. Excel. Okay, so here we have a data. Nearly 150 records are there. So we can have 150 records here, and the top we can have a classifications. I mean different features: sepal length, sepal width, and petal length, petal width. We have a category. Last one is the category class. This is the target class, and all those features are listed here. Okay, so this data I'm going to use it. So here using Pandas, okay, we have two different packages here. One is Pandas and another one is Numpy. Okay, so here import Numpy as NP. NP is a short name for Numpy. You can give any name to the package and using that name for further process. Okay, so we have two packages, Numpy and Pandas, because we have to store the data in either two forms. One is array form, another one is the data frame format. So that's why we have two packages. And matplot, it's mainly for displaying the content. So if you need images, if you want to display, you can display. Otherwise, no need for this one. Okay, so Pandas short name is PD. Okay, you can give A, B, C, whatever name you want. So PD dot read CSV. Can you see the screen, students? Yes. Yes.
Yes, yes, Saleem, we are seeing.
Okay. Okay. Okay.
Yes, correct.
So Pandas to read the CSV. Okay. So you can also use to create empty pandas. Okay. Like df equal pd dot data frame. Data frame, you can give the list. Here you have to give the list. Okay. So you can have a list of data. You can have a list of data. Okay. For example, for here we have a list of data 1, 2, 3, 4, 5. So we can have, so that list of data, you can give it here as a list. Okay. So you can easily create data frames. Okay. But here what we do, okay, what we do here is, we read the data from the file is.csv. So that file, we store it in a data frame. Df, you can give any variable name, no problem. Okay, so df is a data frame. Here you can see we have to, second step of our machine learning is you have to split your features and target variables, right? So here we split, okay, all the data from column 0 to, column 1 to column 4, all the data will be for features. Fifth column is for target class. Okay, so I will show you again. Okay, so column 0, 1, 2, 3, 4. Okay, so here 1, 2, 3, 4. All the rows from 1 to 150. Okay, all the rows from 1 to 150, it will be taken. Okay, so you can see here that the description here is very important, because when you process your data, you have to know what are the columns or the features. Okay, so here 1 to 5. Okay, actually if you give 0 to 5, this will also take it. So here I will give, omit this one, only I will take this 4 columns. Okay, so 0 to 4, sorry, 1 to 4. Okay, but here it will say 1 to 5. Why? Because this is for row. If you give 2 columns, excuse me, any doubts? Devi Priya, any doubts?
You mute your, if you have no doubts, mute your system audio.
Okay, so here again we come back to the topic. Say here I'll give double colon, because this first part is for row and this first part is for the column. Okay, so the first part here I'll give double colon, because we start from the 1 to last row. We'll take all the value, all the rows. So I'll put 2 colons, that will take fully. Okay, so if you give limits here, then it will take only that limited rows. Okay, so here I'll give 1 to 5. That means it will take the column from 1 to 4. It will not take 5, so it will take 1 to 4. Okay, so all the column from here to here we consider for a features. Okay, so feature set is here X. Okay, and Y is the target class. Y is the target class. That means all the row we have to take, but only one column. Okay, so fifth column is the target. Okay, so fifth column, only I'm giving the fifth column. There is no range here, so I'm directly giving the particular column. So all the values in the particular column, it will be taken. So, okay, so you can see some samples here. Okay, so print take yes. Okay, so you can see when you run. So still it is processing. We have a yes. Okay, so you can see all the columns are coming, right? So all the values it takes, okay, and automatically it will index. Right? Next is if you want to display Y, okay, when you run. Y is smaller, so we have to keep all the value on the particular column we displayed. Okay, this is for your understanding. Okay, no need to display. Okay, we have to make sure we have taken all the data. Okay, any doubt in this up to loading the data?
No, Saleem, you can proceed. This table is for 150 flowers, okay?
Yes.
Yes, okay. Okay.
Okay, so next is we have to go for we have to split training and testing. Okay, so here I'll take training set 70%, testing set is sizes 30%, so 0.3. So automatically training set size it will take. If you want to have training size also you can give, no problem if you give only testing size. Okay, and also random any numbers if you give, it will automatically shuffle the data. Okay, it will automatically sorry, if you not give if it is none, it will shuffle the data. If you give any number, then your output, your accuracy will be consistent. Okay, so this is the training test split. So we will get 4 different values. Okay, x train, and x test. Okay, this is for features. Okay, already we know x is for features and y is for target. So x train is training data for feature training data. Okay, x test is for feature testing data. Okay, and y train for the target class. We have a training data, and y test is for testing data, the target class. Okay, so this is the training testing split. Okay, next is we have to choose the model. So here I'm choosing the model as SVC, support vector machine. There is a algorithm, SVC algorithm. So here if you want to know more about SVC, you can have a Google page for scikit-learn. They'll give detailed notes about SVC, what are the parameters here, everything they explain very well. Okay, at the end I will show you the website, you can use it. Okay, kernel we have different option. Okay, sorry. Okay, sorry. So kernel we have a different option. You can choose any of those options based on your problem. And next is we have once you have a model, then you can fit your data to the model. Okay, that means you are feeding your data to the model. Okay, x train and y train. Okay, so those data, this is input data, this is the actual output data you have to give. So automatically the algorithm will create a link between your data. Okay, input and output data, it will automatically create a rules. Okay, so once you have a fitting, the data, next is you have a prediction. So model, it will give predict based on your x test. Okay, so we have a x test data, so that will use for prediction. And once you have predictions, okay, you can check the accuracy. Okay, accuracy score is a method you can able to check your accuracy by comparing your prediction and your test. Okay, comparing your x test and y test. Okay, that is your prediction and your y test. You can get the accuracy. Okay, so that is what given here. So we have a data. First, we'll run the training testing split. Okay, once it is training testing split, we have a model to train. Okay, once you have a model to train, then you can check your accuracy. Okay, so here is the accuracy. Okay, if you want to change your training test split, for example, test split is 4, that means 60% for training and 40% for testing. Okay, so we have a model, and after model we have a, so first I have to train and test split, then I have to give the training testing, then I'll have a, so you can see accuracies differ. Okay, because you know the testing different size of data. Training data, if it's more, your accuracy will be more. Okay, if training data is less, your accuracy will also very less. Is it clear now? The steps are clear now? Yes, we will move to feature extraction. Okay, So I explained already how to read the images, okay, how to change to grayscale image, and how to apply. If you have a data in your hand as a file, then you can able to test your machine learning algorithm. Okay, I explained this. Move to, yes, ma'am. Any queries? No? Okay. We'll move to the second part. Okay. The second part is of our classes. We have to take the grayscale value of the picture. Okay. So in the presentation, I explained three different methods. First one is the grayscale, how to take the grayscale value as a feature. Yes, ma'am.
Actually, it's a box. Shall we give features in text?
Ma'am, voice is not clear, ma'am. Can you please tell me again?
Okay.
Ma'am, please ask your question again. Shall I continue, ma'am?
Sir, excuse me. When we give the features in terms of text,
yes.
What is
when we give the features in terms of text, will it reflect in your accuracy, sir?
Yes, ma'am. If you have a categorical data.
Do we get major difference between the accuracy when we are giving the data, that is features in numbers, and then instead of giving the
any
can
one
you hear
format
me?
you have to use. Yes, ma'am. Yes, ma'am. Actually, ma'am, if you have prepare a data set for your machine learning, either you go for text data or fully text data or fully numerical data. So that will give you more accuracy, because if you have mixed data, sometimes we have mixed data. Okay, we have a text and we have a numbers. Okay, in that time, shall I proceed, ma'am?
Yeah. Yes,
Okay.
sir.
So if you have a text data, some columns we have a text data, some columns we have a numerical data, then you have to change your text data into numeric, or your numeric data into normal text format. Okay. So in that case, we have some methods, ma'am. Pre-processing, data pre-processing. There are bundles of method to process our data. So one of the method is one-hot encoding method in Python. So that will make your text data into numerical data. Okay, so once you have all the similar data, then your scaling will be easy. Okay, even though we have, I will come to the last, ma'am. Okay, what are the problems can come, how to address those problems, I will come to the end of the session. So then you will get a clear idea how to proceed with your, how to prepare your data. Okay, shall I proceed, ma'am?
Thank you, sir.
Okay, ma'am. So here we'll come to first part is feature extraction. That is for so we have three methods. One is grayscale pixel values. Another one is the edge filters. Third one is the mean value of channels. Okay, image channels. So first I'll go with grayscale pictures. Okay. So here. So I have a two set of images. You can see here. I have a two set of images, split images. Okay, one is cat. Okay, cat images, different images I have. Okay, similarly, I have a dog images. So I want to differentiate either cat or dog. Okay, when I give testing, so it has to classify as a dog or cat. Okay, so we have to. So excuse me. Okay. Right, so we have to read those data. After reading the data, I write those data features into one file, that is image data file. Okay, I will show you here image data file. Okay, so you can see image data after extraction. After extractions, here I have Okay, I will delete and create again for your understanding. You can see here all the pixel values. I read it. Okay, so it is nearly 2,500 columns. 2,500 columns. Okay, so I read all the pixel values. At the last, here I gave a categorical value, that is the target value, cat or dog. Okay, so here I choose only 20 data. Okay, 20 images and 20 cat images, 20 dog images. Okay, so in order to run quickly, so I reduce the image. So we have a bunches of images. Okay, we have a set. Goggle is a portal. Okay, so you can have bundles of images for processing. Animals, for example, I'll show it here. So pet images. So we have a huge number of images we have. So from this, I'm choosing only 20 images. Okay, 21 images. Okay, from dog we have a bunches of images. Okay, so all the images we can load, no problem. We can process quickly. Okay, but for time constraint, I take only 20. Okay, so I have a folder, cat 21 images and dog 21 images. Okay, so here I delete the image data because we are going to create again. Okay, so I delete it, image data. Okay, so no image data in my folder. Okay, so here I'll refresh. So you can see there is no image data here. I will extract now. So here what I did, I read all the images from cat folder. Okay, so I'm using here as IM read collection. So it will read all the images from the folder, and every image. Okay, so I'll read the image by after reading it, I have to store the image in a variable. After storing it, I have to change the image as a grayscale because color image, it occupies more pixel value. So I'll reduce to grayscale. Okay, so then after changing to grayscale, then I resize the image because the image size is big. So I reduce to 50 into 50. That's why I have 2,500 columns. Otherwise, it will be very big. Okay, I did not process any pictures. Okay, what is needed, what is not needed, I did not do anything. I just take all the pixel values and put it in a array. Okay, so I read all the pixel values and I reduce the image size. Okay, after reducing the image size, I make it the pixel array. Pixel array is a flatten. Okay, here you see Numpy. Numpy is used here. It will make your array into one row, full row. Actually, it is 2D array. Okay, now we are changing that array into one row. Okay, one full row. Okay, after having the full row, okay, I added that row in a list. Then I used to write the data into this file. Okay, so we will see here same way I also did for dog images. Okay, so two category of images, one is cat, another one is dog. At the end of all the data, I added cat and dog. Okay, the category, the target class. Okay, so here I added cat and dog. Okay, so once I run this program, you can see the file will be created. Okay, so and we have our image data. So you can see image data. You can also see in Excel. Some places it has 1, some places it has less than 1. There are 2 levels, grayscale. So the values are stored here. And at the end, you can see we have a category. So we have a category cat, okay, and also we have a category dog, okay. So totally we have 42 records, very less data. So accuracy will also affect, okay, when you have very less data. So only 42 records. Okay, in order to show you a demo, so I'll take only very less amount of data. If you want to process all the images that you have, you can do. Okay. So next is after pre-processing. After pre-processing, we can directly move to our model. Okay, here I'm using logistic regression because our testing is categorical based. One is dog or cat. Okay, only two choices. Okay, we are not having continuous values. Okay, only we have two categories. So I'm choosing logistic regression. Okay, if you want to test with SVM, you can do it. Okay, best model for your data, you can select it. Okay, so same like we load the data, PD, that means Pandas data frame. We load the CSV file, which just we created, right? Image data.csv, that is we created just before, the same data file. Okay, so once your data file is ready, okay, next is you can able to shuffle the data. If you want to shuffle the data, you can shuffle. Okay, because training, if shuffling is I mean, if you add shuffle your data, then your training data and testing data combination will be strong. Okay. Next is you have to check your, you have to split your features and your target class. So as I already said, we take all the features from 1 to 2500. Okay. Then we also have a target class. Okay, target class we have. Okay, so we take all the values. Next is we can go for testing, training and testing split. Okay, so here we have a training testing split. Okay, so model. After creating training testing split, we have 4 different values. Okay, then we choose the logistic regression. Okay, logistic regression is a sigmoid function. Okay, you can see what is sigmoid function or what is linear regression, how it is different from linear to logistic. You can go through the contents in the websites. Okay, you will get more idea. Then we have a training and testing split. Training and training testing split. We choose training data for a model. Okay, X train and Y train. Okay, after we feed the data to model, then we go for prediction. After prediction, we can able to display the details. Okay, so here I'll disable all these things. Okay, and this I will show you after our predictions. Okay. When I run it, you can see. Yes. Right, so we can see the results. So this is the confusion matrix. Confusion matrix means nothing. In the PPT last slide, I displayed regarding accuracy calculation. So that is the confusion matrix. Okay, positive and negatives, right? True positive, true negative. That table is the confusion matrix. So here is a confusion matrix. Okay. And we have 2 categories, star, dog, and cat. Okay, so the accuracy of the prediction is given here. Okay, so accuracy, we have different precisions, recall, F1 score, support. Okay, so everything you can explore. What is precision? What is recall? What is F1? Here I just focus on accuracy, because we have very less amount of data, so our accuracy is very less, 62%. Okay, if you have more data, your accuracy will be more. Okay, so this is for prediction model. And suppose you want to check for your test data. Okay, you can take any one row as a sample, and you can able to test it. Okay, how to do this? Here I choose one record. Okay, here I choose one record. Okay, so that record. We have a X and Y record. Okay, X is for features and Y is for target. Okay, so I take some sample data. Okay, take some sample data and I test it with prediction. Okay, so what will be my prediction? Okay, so we can see Okay, so it says due to some accuracy, you can see here accuracy is changed for 64 to 46. Repeatedly, you have to do nearly you have to do trying for 10 times or 20 times. Then you take the average accuracy from the model, or you can go for direct validations, validation functions that will validate fully, and finally they will give the it will give the accuracy results. Okay, so here my sample is dog. Okay, but actually predict as a cat. Okay, that is wrong actually. So that's why accuracy is less. Okay, again I run. We will see what will happen. Okay, so accuracy again it is less. Okay, again I'll run. Okay, so here you have accuracy is high because we shuffle the data, and every time the sampling and training is different. Okay, so here I have a dog data. It also predicts 100 accuracy as dog. Okay, so this is the way we can able to test our data. Okay, so from the image we take the data and we implement with take the data as a image data, and we change it to text file, and we feed the file to machine learning model. It will give the results. Okay, this is one way. Another way is another model is another method. Okay, so we have a second one is the just a minute. Second one is the edge features. Okay, take some water. So how to extract the edge features? Okay, so here for edge detections, I use Gaussian filter. You can use Canny, you can use Sobel, you can use different filters, image filters. I hope you may have some idea about edge detection filters. Okay. So right, so we have a data, so cat data. So when you read the cat data, so after loading the cat data, okay, so you change to grayscale mode. After changing the grayscale mode, you reduce the size. Okay, after reducing the size, we have a filter. We apply Gaussian filter. Okay, so if you want to see the Gaussian filter, you can able to see by giving after filter. Okay, after filter, if you want to see the image, you can able to see the image by using once you store the image. Okay, so you can able to see by using IM show. Okay, so if you draw this, if you write this line, you can able to see the image, because this is now it is in looping. Okay, so if you put that image to view every time, then it will be a big issue. So I did not include IM show in the data processing. Okay, so I read image after applying Gaussian filter. Okay, so I read the image and reshape the image into one row. Okay, then I add the data to a list. Finally, I add the class. Okay, what is the last category? Okay, category of the data. So after I added all the data, then I'll go for writing the file. Okay, writing the data to the file. So it will write the data as a row. Okay, usually when you take a data, when you try to write data into a file, it will be like a column. It will write in a column. Okay, so you have a proper method to write your data as a row. Okay, here we have a write row method to write your data into as a row. Okay, you can able to write a data in a row. Okay, next is same way, we also have a dog image. We process it. Okay, then we apply Gaussian filter. After applying Gaussian filter, we do the reshape. Then we take all the data from the image and we store it in a file. Okay, so is it clear now? Any doubts about the edge detection filter? Any doubts about this? Okay, so we can move, right? So we have a data. Okay, once you write, okay, I'll run this file. We have a image data filter file. So already the file is there. I will delete that file. So I will delete all these files. Okay, so you have a delete. Delete. Yes, we delete that data. Okay, so I will run it again. So yes, it's finished now. So you can see the filter. Our file name is image data filter. Okay. Image data here. So image data filter, when I open. Okay, all those data are available here. Okay, at the last we have a category. The last we have a category. Okay, so data is available. Okay, next is same way we apply filters. Okay, same SVC filter, SVC model here I used. Okay, so we read the data, we split the data. After we split the training and testing data. Then we go for model testing. Okay, so SVC logistic regression we used previously, right? So here we use SVC gamma value. It will support vector machine. When you go to that, it will classify the item. Okay, and it will draw the margin. I mean, it will separate the category of data. Okay, and it will find nearest value. Okay, then only we can have a classification accuracy will be more. Okay, so that support vector mission we used. So gamma is one of the parameter, and many parameters are there. You can check what are all the parameters, and you can modify those parameters. It will give different results. Okay, after preparing model, we go for training. Okay, we'll go for training. That is fitting. After fitting, we'll do for prediction. Okay, and the prediction accuracy is displayed here. Okay, so I'll just close this one because a lot of output. So we will give it here. You can see. Sorry. So our accuracy is very less. Okay, so again, when you run. And all those printing, so it will give your output. So our accuracy is very less. Okay, again, if you run, again it is going down. So when you apply SVM, okay, when you apply SVM, your prediction model gives the very low accuracy, Okay, if you give dog, it will predict as cat. Okay, so you have to choose some other model, or you can refine your data. So that it will perfectly suit for SVM. Okay. Next, we move to another one. Yes.
Yes. Actually, since it is using the edges,
Yes, ma'am.
I think it will not find much difference between cat and dog edges. Maybe.
Yes.
That
So
may
I'm
be confused. Happens.
I'm taking as a sample. You can take any kind of data. Okay.
Okay. Continue.
Okay. And moreover, we have a very less data, only 41 records. Minimum, if you have 1,000 records, then you will get a good accuracy.
Yes. Okay.
Okay. So next is we move to the last one, mean pixel values. Okay, how we have to take mean pixel values, because we have 3 channels. Okay, red, green, blue. Okay, so all the 3 channels, we'll take the pixel and we'll finally create a new array with a mean value of that pixels. Okay, here we read the data. Okay, once you have the image, then you can go for resizing the image. Okay, so here I added some features. Okay, some parameters here. Preserve the range. Okay, preserve the range. Previously, when we have a grayscale, all the pixel values between 0 and 1. Okay, the pixel values are 0s and 1. Here we are taking the color image. Okay, so we have a color image. So in that case, we have to keep the pixel value as such so that we'll get the mean value, good mean values. Okay, so we have we preserve the range, and also we convert the data as a int, unsigned int. Okay. Same like anti-aliasing. So we reduce, we ignore the zigzags. Okay. So we resize the image. After resizing, okay, we have to take the channels. We have to take the channels. Okay. So we have 3 channels. So all the 3 channels values separately we have to take. How to take the channels value? We have a shape. Okay. The shape which will display how many channels you have. So it's an array. Okay, so channel 1, channel 2. Okay, third one is the color intensity. So that channel you have here. Okay, so first channel value, second channel value, and third channel value. So we take it and we'll take an average and we'll put in a feature matrix. Okay, feature matrix is just we created here. Okay, it's an empty matrix which having the same size of the original image. Okay. Whatever image size 50-50, the same size, we create a dummy array matrix. Okay, once you have a mean value, the mean value will be stored in the feature matrix. Okay, once you have a feature matrix, then you can make it as a flat. Okay, single dimension. Okay, single row. You make it as a single row, then we add it to the file. Okay, same way we do for the dog image. Okay, so now we have to create that one. Okay, so I'll delete this channel. Okay, so channel file, right? So here also it will remove. Channel file is no more here. I'll take that one and I'll run. Yes, it's finished. Okay, so we can see our values. Okay, so all the values you can see, it is not 0 and 1, it is an actual pixel value, and we take the average. Okay, so at last, as usual, we'll add the target. At last, we add the target value. Okay, so this is one. After this, we go for modeling. Okay, again, I use SVC, same SVC model. Okay, and I will run. So you can see the output accuracy levels. Okay, so here also we have very less accuracy. When you run again, test, at least we have 50% accuracy. Okay, so that's why we have a dog. If you give dog, it will give also result as dog. Okay, so accuracy level bit increased. Okay, repeatedly you have to test it. Okay, repeatedly you have to test it, and you will take the average accuracy level. Okay. So for any doubts, students, please give your feedback. Then we move to Java, how to configure your Java environment, how to process your image. Okay, any doubts?
Sir, if we change the image size, it will affect the result or enhance
Yes,
the
of
result?
course. Yes, of course. Okay, here I am consider only dog and cat. Both are structure-wise, it is similar.
Yes, sir.
Okay, so you can take even Sachin image and Dhoni image. You can classify either Sachin or Dhoni. You can do it, or you can take different medical images. Okay, brain image
Yes.
and or different parts of the body image, X-rays image. You can apply these filters, take the edges, and again you can process the test your model.
Okay, sir. Okay, thank you.
Okay, ma'am.
Saleem, some more
Shall we
questions
move
are there. Some more questions are there.
Yes,
Shall I
yes,
read
ma'am.
it?
Yes, yes, ma'am.
Okay, Kalichelvi Nagarajan asking how to pre-process the feature set.
Pre-process your feature set. You have to study Pandas. Okay. Okay, what are the functions inside the Pandas for pre-processing? First thing, while pre-process, you have to move the data in one scale. You understand, I think. Okay. Here, we take the pixels, our range is 0 to 255, right? So we have a range, okay? Similarly, when you have a data, real-time data, when you take it, okay, really it is very difficult to prepare in one scale. Okay, sometimes data, one column data, it can be vary from 0 to 2000. Another data is vary from 0 to 1. Another data is very different scales. Then you have to scale the data. Okay, one data you have to do transformation, and you have to data that will suit for your model. That is one thing. That process you can do with the Pandas. Second one, missing data. Sometimes while doing the pre-processing, while writing the data, some data will be missed. So you have to take value or nearby value. You have to take the average and you have to replace the missing value. Okay. Third, sometimes you have a wrong entries of the data inside, so you have to replace that values. Okay, so all activities you have to do with Pandas.
Okay, somebody asking about this duplicate value also.
Yeah, duplicate also you can remove. Duplicate values also remove by using Pandas. We have a lots and lots of methods we can do it.
Okay, sorry.
Okay, so any other queries, man?
So you likewise, what about the significance testing? Somebody asking.
Yeah, significance. Significant in the you mean data features and results? Yes.
What is your question, Kalicheri? Significant testing of models, to test the models.
You mean how to choose your model?
Yeah, there may be chances for several models are available, no? So how can we test the significance of model? I think some statistical test we have to do for that. Yes.
Yes. Whether it is a linear, your data is very linear, then you can go for the linear classification models. Okay, if it is categorical, if your data is categorical, then you go for categorical model. Or if your process is just to group the data, then you go for clustering model. Okay, different model. Okay, another thing is you have to measure your features, how much is connected with your target value. Okay. Your features is not fully contributed to target value, then those features you can easily remove. Okay. So that for that case, if you want to measure your features value, we have different covariance. We can able to measure the relationship between one data with another data. Correlation you can do. Okay, so correlation results gives good. Okay, then all the feature data that will relate to the target data, then you can directly go for your model. Okay, sometimes take different bundles of features. Okay, 1,000 features we have, but all 1,000 features are not suitable for your model.
Okay.
And if you want to do reductions, okay, dimension reduction, if you want to remove some features, okay, automatically if you want to do manually, you can do after analyzing correlation or covariance, then you can easily remove the columns. But if you want to do automatically, then you go with the PCA, principal component analysis, and some more methods some dimension reduction methods. Okay.
LD until available. Yes, yes. Okay.
Yes. A skit image package we have, and also we have Pandas. We have some packages to dimension reduction.
Okay.
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 Shall we move on? Any more queries?
That's all. That's all. That's all.
Okay. Okay. Next is I'll just log out this one. We will go for Java. Okay, so it means I hope everyone knows NetBeans, right? At least you may have working experience with NetBeans or Eclipse, right? Because in Java, I had to explore many things. Okay, so I just focus on Python only. Okay, for your some people, they are very good in Java. They can do any kind of task with the Java. So you can also do with Java. Okay, it is not only you have to depend on Python. Okay, you can also do with Java. First, I'll show you how to read the image. Okay, so here two important jar files you need. Okay, for doing image processing with Java. One is Opencv. Okay, Opencv is for image processing, digital image processing, and another one is the Weka. Weka is a tool for machine learning. Okay, Weka is a tool for data mining. Weka is a tool for machine learning. Weka is a tool for many analytical works. Okay, so you have to include, you have to download two jar files. First one is the Weka, another one is the Opencv. Okay, how to download this? We have a link. We have a website. You can easily download. Okay, so for example, I need a Opencv, or you can download Opencv for Java. Okay, so we have a websites you can download. Okay, so this is a tutorial, and we have a download. We have downloads. Okay, so we can have a link to download. Okay, so you can go for downloading options here in the website, and you can download it, or you can directly download from the Google. Okay, Opencv Java jar. Okay, so we can download directly. Okay, Opencv jar files. Okay, you can download. How to configure, everything is given. You can easily download. Okay, so from the way you can easily download, you can also download Weka jar. Okay, Weka download. Weka image, you can go for download. You can download the Weka image. You have a jar file in the folder. You can use that jar file. Okay, so I have two jar files. I added to those jar files here. How to add this jar files? You can go to the libraries. Should I explain how to create a project in NetBeans? Or you know the project, how to create a project, how to work with Java? Students? Students, you know how to create a project, right?
Yeah, they can understand. You proceed, Saleem. They can understand.
Okay. So if you want to have a new project, you have to create a new project. Okay. So here, new project, and you have to select Java application. Okay, because different components you can create with Java. Okay, so with NetBeans. Okay, so you have to choose Java application, and you go for next dialog box, and here you have to choose your project name. Okay, you can give your project name and your JDK, where you have JDK. Okay, everything is automatically detected. When you install Java, it automatically detects your JDK. Okay, if not, you can give your JDK, where you have your JDK, you can select it, it will work fine. Okay, so once you click finish, automatically the project will be added here. Okay, so I did not change any project names, just I keep the same name what it displays. Okay, in the project, okay, I'll minimize all those things. So in the project, we have a class file. We have a class file. You can do for coding. If you want to add more class files, you can right click. You can add Java class. Okay, you can create n number of classes that you want. Okay. Next is library. How to add the Weka library? How to add the Opencv jar files? Okay. So you have to go with libraries here. Add library, you can choose. I already add the Weka jar here, sorry, Opencv jar here. So I can able to select the Opencv jar and just click add library, it will be added. And also I already have a Weka jar. So if you select Weka jar, when you install Weka, automatically jar file will also be there in the folder. You can select the Weka jar. Okay, so it will also add it in your library. Okay, very simple. No need to do a complex thing. You have 2 jar files because that package you need for write your codings. Okay, so now I'll directly move to the coding part. Okay, so here first one, to read the image. I already told you I'm not fully comfortable with Java because I work with Python. Okay, for your understanding, for your benefits, we have both options. Okay, we can use either Python or we have a Java. Okay, so I have a class. In the class, I have a main method. Okay, so in the main method, we read the image. We read the image, and while reading the image, we convert into grayscale. Okay, how to read image? We have a imRead function. imRead function. Okay, imRead function comes under the package image codecs. It is in Opencv. Okay, it is in Opencv. Okay, once you have an instance, you can able to read the image. You can able to read the image. While reading, it will change to grayscale. It will move to grayscale. And it will be stored in a matrix. Okay, the matrix package will also in Opencv. Okay, matrix package will also in Opencv. You can have all the packages here. I will share this code. You can also use it. Okay, so we have a matrix. Once you read the image, it will be in a matrix. Okay, once you have a matrix, you convert the matrix, you can able to view the image. Okay, this is the way you have to load the image into matrix. Once you have a matrix, you can able to view your image by using JFrame, Java JFrame. You can able to view your images. Okay, so I will run this program. You can able to see the image. So we read one image. Okay, so the bird image, we change to grayscale. Okay, so it is like a grayscale image. Okay, you can see here, images here. Okay, so we know how to read the image, and store it as a matrix. Okay, next is our task is very simple. We have to change this matrix into one row. Okay, we have to change this matrix into one row. Then we'll write to CSV file. It's very simple. So we have to go with feature extraction program. I just make it separate so that you can able to find the code, relevant code. Okay, so after reading the image, okay, so we reduce the size of the image and we create a new image. Okay, so we create a new image with our reduced size. Okay, once you have an image, you can see how many rows and columns are there, the size of the image. You can able to see Okay, next is you have to change this image features, all the pixel values, the matrix which we have. Okay, so that features we have to write it in a CSV file. So we have a file writer, file writer class. Using the file writer class, we can able to write our content into a file. Okay, so we have that. Okay, next is I use string buffer because we have to store all the pixel values, one image, all the pixel values we have to store as a string. Then I'll keep that string as a data into a file. Okay, so I'll read the row. I'll read row by row because we have a 2 dimensions, right? Images in 2 dimension. We have number of rows and columns. I'll take all the columns and I'll read row by row. I'll make it as a one string. I'll merge all the row into one string for one image. Then I'll prepare for. Okay, so this is the way we have to read one by one. Okay, row 0.dump, that will take full row values, all the row values, all the pixel values it will take, and it will store in a string. Okay, it will be like a list. It will be like a list. Okay, so I just remove what are the additional special characters in it. So I just remove all the special characters. Okay, then I will add that string into a string buffer. I'll add the string into string buffer pixel values. Okay, so it will change. It will change all your image pixels into one row. Okay, one string. Okay. For example, if you have 50 into 50, the image, image size, you have a 2,500 data as a feature. Okay, so that will be in a pixel value. Once you have a pixel values, then you write the data into file. Okay, so CSV writer, it will write. Okay, CSV writer object that we already create file writer. Okay, so that will write our content to the file. Okay, so now we will check it now how the data will be stored in the file. Okay, so here we have a data new. Okay, that I will store it in D drive in the download. Okay, so if you want to have new data, okay, so here I'll give sample file .csv. It will be stored in download a D drive, D folder, and inside D folder I have a CSV file. Okay, so I will run this file now. Okay, so CSV file is created, so we can go to downloads and D drive. We have a sample file. Okay, so all the pixel values you can see. So all the pixel values, we keep it. This is, I took it for one image. Okay, so same way you have to repeat for all your images. You have to put it in a loop. You have to read one by one all the images, and you have to convert as a single row. Okay, then you have to write it in a file, CSV file. Okay, at the last we have a target values. Okay, is it clear now how to prepare your data using Java?
Image data as a CSV. It's clear. It's clear.
Okay. So next is we have to apply machine learning. Okay. So for applying learning, we have to use Weka. Okay. So you have a Weka tool. I will show you. Next is I have a Weka tool. So hope you all are know about Weka. It's mainly used for data analytical purpose. Okay, so here you can directly, if you prepare your data, no need to do any codings. Okay, no need to do any codings. You can directly feed all those data into Weka in a GUI mode. Okay, we can also do program wise. Okay, we can also do program wise. But which is comfortable to you, you can use. If you want to write in a program, okay, you can do. Or if you want to do as a plug and play model, you can use GUI. Okay, so open file. Okay, usually Weka, we use R file model. Okay, so you have to choose even we can use CSV file also. Okay, but ARF is the best model for Weka. Okay, so I have a ARF files. Okay, CSV, we have CSV files, and we also have ARF file. Yes, we have two ARF files. Okay, one is iris. Already we have a data, right? So we have a iris data ARF file. Once I load it, you can see all the features here. It will display. Okay, and relationship between the features are displayed here. If you choose which features are required, okay, based on that, the feature frequencies are displayed in the right side. You can see feature frequencies are displayed. Okay, so here I choose all the columns. Okay, all the columns here I choose. Okay, so all the features I choose. Next is I have to choose classify tab. So here I have to choose the models. Okay, classifier. Different classifiers are there. Logistic. You can see here automatically which is suitable for the particular data. It will detect and it will enable only those models. Okay, SMO is for SVC model. Okay, support vector machine. Okay, so that model I choose. And cross validation, as I said already. Okay, so if you want to have good accuracy, you have to do cross validations. So 10-fold validation. This is you can also do with Python. Okay, by coding you can also do it with Python. Okay, once everything is ready, you can go for start classifications. You can able to get your accuracy here. Okay, you can able to get your accuracy here. This is your confusion matrix, and all your frequency, all your accuracy details are displayed here. Okay, so this is the simple way you can explore machine learning. Okay, and another way is you can directly do the coding. Okay, you can directly do the coding. Okay, so first thing what I did, I changed a CSV file to R file. For the comfortability. So because our file, we have some description about every features. Okay, then we have a data, then we have a target class. So it will group the data as like that. Okay, so I just change my CSV to R file. Okay, so we have a CSV loader. Okay, CSV loader file. It will load the CSV file and it will save the file in ARF model by using ARF saver class. That will help you to save your data in ARF format. Okay, so once you have ARF format, you can go for classification. Okay, so here is the classification. So here I choose decision tree. One of the algorithm is J48 algorithm, decision tree algorithm. Okay, so I have a data, ARF data. Okay, I have a data, iris ARF data. Then once you have the data, you have to load the data by using data source class. Okay, then you have to create an instance for data set. Okay, after creating the instance, you go for your model. You can go for your model. So here you have to classify the features. Okay, which is feature, which is not the what are the features and what are targets. So you have to split it here. After splitting it, you can go for the model. You have to create object for J48 class, and you can go for the testing. Okay, so you have to feed your data. Automatically, it will split testing and training. Okay, once it is finished, you can get the results of your testing. Okay, so I will run it here. You can see the accuracy, same accuracy which we have in our Weka tool, right? Same accuracy you will also get here. Okay, so any doubt in this? I will share this code. You can use it. We can also use different class models. Okay, so just I make it comment here. So that you can also use naive-Bayes. You can use SVM. Different models you can test, and you have to select which model is best for your data. Okay, I hope the session will be useful to you. If you have any queries, please ask your query now. Students, any questions?
Yeah. Yes.
Yes. Yes.
They're getting ready, it seems. Actually, this is Java is simple, I think. I don't know if it's simple, but we can understand very well, Saleem. Even Python, I don't know, since we're working with Java, na, so it's very familiar to us while seeing the screen, everything.
It's our comfortability, ma'am. I feel Python is much simpler because all my operations be much quicker, and you can able to extract bundles of data, big data.
Okay, yes. When the packages, lot of packages are available there, but even in the Java
Yes.
also it's available, I think. But anyway, everyone are getting used with this Python only, na. So
Yes. And
but
if you want to practice with the deep learning, you can use TensorFlow. Google TensorFlow is very good software for. This is not under Python. Okay, so you can use TensorFlow.
Okay.
And if you create a model, real-time model, okay, if you want to create a product, so how can you import your data to website, or how to test your Python code into website? We have tools for it. Okay, you can able to connect your Python into web page. Okay, so we have a different tools to use it.
Okay. Even we can convert them into a mobile app also, no?
Yes, ma'am.
Yeah, for that also.
Once you convert into if you do the coding in Java, it's much easier to combine with mobile.
Mobile, yeah, that's my feeling. That's what I asked you to go with Java also. Okay, in future let us check which will be useful for us. Then and that's the platform we will go. Okay, it's actually really useful very much for us, Saleem.
Thank you, ma'am.
Actually, madam has afternoon when she entered inside, you left the meeting. She called you, scheduled you, madam.
Okay.
Madam will join this. Okay.
Madam, good evening, madam.
Thank you, ma'am. Dr. Thank you very much. Hello, Dr. Saleem. How are you?
Yeah, fine, ma'am.
Okay. So thanks for your concern to serve as a very powerful resource person in AIMS 2021.